Understanding climate change. Global warming and climate change can both refer to the currently observed century scale rise in the average temperature of the Earth's climate system and its related effects. But climate change can also refer to any historic change in climate. Multiple lines of scientific evidence show that the climate system is warming. More than 90% of the additional energy stored in the climate system since 1970 has gone into ocean warming. The remainder has melted ice and warmed the continents and atmosphere. Many of the observed changes since the 1950s are unprecedented over decades to millennia. Scientific understanding of global warming has been increasing. In its fifth assessment in 2014, the Intergovernmental Panel on Climate Change reported that scientists were more than 95% certain that most of the global warming is caused by increasing concentrations of greenhouse gases and other human activities. Climate model projections summarized in the report indicated that during the 21st century, the global surface temperature is likely to rise a further zero point 0.3 to 1.7 degrees C for their lowest emissions scenario using stringent mitigation and 2.6 to 4.8 degrees C for their highest. These findings have been recognized by the national science academics of the major industrialized nations. Future climate change and associated impacts will differ from region to region around the globe. The effects of an increase in global temperature include a rise in sea levels and a change in the amount and pattern of precipitation, as well as a probable expansion of subtropical deserts. Warming is expected to be strongest in the Arctic, with the continuing retreat of glaciers, permafrost, and sea ice. Other likely effects of the warming include more frequent extreme weather events, including heat waves, droughts, heavy rainfall, and heavy snowfall, ocean acidification, and species extinctions due to shifting temperature regimes. Effects significant to humans include the threat to food security from decreasing the crop yields and the loss of habitat from inundation. The greenhouse effect is one process that is considered to be an agent for climate change. The greenhouse effect is the process by which absorption and emission of infrared radiation by gases in a plant's atmosphere warm its lower atmosphere and surface. It was proposed by Joseph Fourier in 1824, discovered in 1860 by John Tyndall, first investigated quantitatively by Svante Arrhenius in 1896, and developed in the 1930s through 1960s by Guy Stewart Callendar. On Earth, naturally occurring amounts of greenhouse gases have a mean warming effect of about 33 degrees C. Without the Earth's atmosphere, the Earth's average temperature would be well below the freezing temperature of water. The major greenhouse gases are water vapor, which cause about 36 to 70% of the greenhouse effect, carbon dioxide, which causes 9 to 26%, methane, which causes 4 to 9%, and ozone, which causes 3 to 7%. Clouds also affect the radiation balance through cloud forcing, similar to greenhouse gases. Human activity since the Industrial Revolution has increased the amount of greenhouse gases in the atmosphere, leading to increased radiative forcing from CO2, methane, tropospheric ozone, CFCs, and nitrous oxide. According to work published in 2007, the concentrations of CO2 and methane have increased by 36% and 148% respectively since 1750. These levels are much higher than that at any time during the last 80,000 years. The period for which reliable data has been extracted from ice cores. Less direct geological evidence indicates that CO2 values higher than this were last seen about 20 million years ago. Fossil fuel burning has produced about three quarters of the increase in CO2 from human activity over the past 20 years. The rest of this increase is caused mostly by changes in land use, particularly deforestation. Estimate of global CO2 emissions in 2011 from fossil fuel combustion, including cement production and gas flaring, was 34.8 billion tons, an increase of 54% above emissions in 1990. Coal burning was responsible for 43% of the total emission, oil 34%, gas 18%, cement 4.9%, and gas flaring 0.7%. In May 2013, it was reported that readings for CO2 taken at the world's primary benchmark site in Mauna Loa, an active volcano on south central Hawaii Island, surpassed 400 ppm. According to Professor Brian Hoskins, this is likely the first time CO2 levels have been this high for about 4.5 million years. Over the last 3 decades of the 20th century, gross domestic product per capita and population growth were the main drivers of increase in greenhouse gas emissions. CO2 emissions are continuing to rise due to the burning of fossil fuels, and land use change is a controversial issue. Emission scenarios, estimates of changes in future emission level of greenhouse gases have been projected that depend upon uncertain economic, sociology, technological, and natural developments. In most scenarios, emissions continue to rise over the century, while in a few, emissions are reduced. Fossil fuel reserves are abundant and will not limit carbon emissions in the 21st century. Emission scenarios combined with modeling of the carbon cycle, have been used to produce estimates of how atmospheric concentrations of greenhouse gases might change in the future.